Great welcome to everyone joining us today on Math Simplified by HM. I thrilled to continue our geometry series as we master the theorem of angle between tangent and secant. Please like the video and share it with your circle. Make sure you are subscribed with notifications turned on to stay updated. Ready? Grab your notebook. Feel free to pause as we go and let us dive in. The theorem of angle between tangent and secant, proving the relationship between an intercepted arc and its boundary angle. The proposition or the theorem: if an angle has its vertex on the circle, its one side touch the circle and the other intersect the circle, then the measure of the angle is half the measure of its intersected arc. We will see the geometric setup given in theorem. Consider a circle with center M. Angle ABC has vertex B directly on the circle. Side BC touches the circle at point B, therefore BC is tangent. Side AB intersect the circle at point A, therefore BA is secant. Arc ADB is intercepted by angle ABC, and we have to prove angle ABC is equal to 1 upon 2 measure of arc ADB. The strategy covering all possibilities. To prove this universally, we must test every possible physical reality. The center M can only exist in 3 specific locations relative to our angle ABC. Center on arm relative to angle ABC, exterior center with respect to angle ABC, interior center with respect to angle ABC. Now case 1, center M lies on arm BA. By the tangent theorem, the radius is perpendicular to the tangent at the point of contact. Therefore, angle ABC is equal to 90 degree. Because BA passes through center M, arc ADB is a semicircle, and the measure of semicircle is 180 degree. Hence, we get 90 degree is equal to 1 upon 2 into 180 degree. Now, 90 degree is angle ABC and 180 degree is the semicircle arc ADB. Therefore, angle ABC is equal to 1 upon 2 measure arc ADB. Case 2, center M exterior of the angle ABC. Draw a diameter BE. From case 1, we know angle ABC is equal to 1 upon 2 measure arc ADB. Now, angle EBA is an inscribed angle intersecting arc EA. So, angle EBA is equal to 1 upon 2 measure of arc EA. Notice that angle ABC is equal to angle EBC minus angle EBA. Substitute the arc measures, we get angle ABC is equal to 1 upon 2 into bracket measure of arc EDB minus measure arc EA. Simplifying subtraction of arcs, we get angle ABC is equal to 1 upon 2 measure of arc ADB. Case 3, center M in the interior of the angle ABC. Again, draw a diameter BE. From case 1, we know angle EBC is equal to 1 upon 2 measure of arc EB. Angle EBA is an inscribed angle intersecting arc EDA. So, angle EBA is equal to 1 upon 2 major arc EDA. Notice that angle ABC is equal to angle EBC plus angle EBA. Substitute the arc measures, we get angle ABC is equal to 1 upon 2 into bracket measure of arc EB plus measure of arc EDA. Adding arcs, we get angle ABC is equal to 1 upon 2 measure of arc ADB. The universal proof. Because all physical possibilities have been accounted for, the theorem is universally proven. Let us recall. Case 1, on arm we have direct foundation. Case 2, center is exterior of the angle. We proved by subtraction of arcs. Case 3, center is interior of the angle. We proved it by addition of the arcs. In each case, angle ABC is equal to 1 upon 2 measure of arc ADB. What a brilliant session we just completed. Truly outstanding logical deduction. Remember the message, go beyond simple memorization, strive for deep comprehension. Let that be your guide in every math problem you solve. I am glad to have you here at Math Simplified by HM. Please show your support by liking and sharing this video with your friends and colleagues. Don't forget to subscribe and hit that bell icon so you are always the first to know when we post. Thanks all for your amazing focus. Have a great time practicing and see you next time.